Assalamu alaikum. Welcome to lecture number 7 of the course on statistics and probability. Students, आपको याद होगा कि पिछले लेक्चर में हमने दो बड़े इंटरेस्टिंग डायग्राम्स डिस्कस किए थे, the stem and leaf plot and the dot plot. After that, I began the discussion of the concept of central tendency. And in that context, I discussed with you in some detail the concept of the mode. Today, I will continue with that concept and will discuss with you the non-modal as well as the bimodal situation. And after that, we will go on to other measures of central tendency. आइए पहले हम उस कॉन्सेप्ट की थोड़ी सी रिवीजन कर लेते हैं जो हमने लास्ट लेक्चर के एंड में किया था. दैट इज द कंप्यूटेशन ऑफ द मोड इन केस ऑफ द फ्रीक्वेंसी डिस्ट्रीब्यूशन ऑफ अ कंटिन्यूअस वेरिएबल. You will recall that I used exactly the same example that we have been using for quite some time now, and that of the EPA mileage ratings of cars. And to that frequency distribution, I applied the formula x hat is equal to L plus Fm minus F1 over Fm minus F1 plus Fm minus F2 into H, where L and Fm, F1, F2, and H all had their particular meanings, which I described. And applying this formula, we obtained x hat equal to 37.825 miles per gallon. उसके बाद हमने मोड की ग्राफिक लोकेशन कंसिडर की थी और उसी डेटा का जो फ्रीक्वेंसी पॉलीगॉन था उसके ऊपर यानी उसके एक्स एक्सिस के ऊपर मोड को लोकेट किया और देखा कि इट वाज लाइंग एग्जैक्टली अंडर द टॉप मोस्ट पॉइंट ऑफ द फ्रीक्वेंसी पॉलीगॉन. जैसा कि आपने देखा, हमारा जो मोड है इस डायग्राम में एक्स एक्सिस पर उस पॉलीगॉन के नीचे सेंटर में लाई कर रहा है, ऑलमोस्ट इन द मिडल. और मैंने लास्ट टाइम भी आपसे यही कहा था कि अक्सर और बेशतर डिस्ट्रीब्यूशंस चूंकि हम्प शेप्ड होती हैं इसी तरह से कि उसका जो मैक्सिमम पॉइंट है वो मिडल में होता है समवॉट, इसलिए द मोड इज रिगार्डेड एज अ मेजर ऑफ सेंट्रल टेंडेंसी. लेट अस कंसोलिडेट दिस कॉन्सेप्ट by going back to the example of the ages of the managers of child care centers that was considered in the last lecture. The students will recall that the example was as follows. The following table contains the ages of 50 managers of child care centers in 5 cities of a developed country. The ages were 42, 26, 32, and so on. Convert this data into a frequency distribution and find the modal age. Now, students, you will recall that following the various steps involved in the construction of a frequency distribution, we obtained classes were 20 to 29, 30 to 39, 40 to 49, and so on. And the frequencies were 6, 18, 11, 11, 3, and 1. Now, in order to find the mode, we note that in this example, we are dealing with a continuous variable, that is age. Hence, the mode is obtained by the formula x hat is equal to L plus Fm minus F1 over Fm minus F1 plus Fm minus F2, and this whole expression multiplied by H. Now, in order to apply this formula, the first step is the determination of the class boundaries, because as you know, L stands for the lower class boundary of the modal class. And as indicated in the last lecture, the class boundaries for this example are 19.5 to 29.5, 29.5 to 39.5, and so on. The maximum frequency, FM, is 18, and it lies in the age group 30 to 39. Therefore, students, the class 30 to 39 is the modal class. And the lower boundary of this particular class is 29.5. In other words, L is equal to 29.5. Now, of course, FM has already been found, but we also need to determine F1 and F2. And going back to the table, we see that F1 is equal to 6 and F2 is equal to 11. जैसा कि पहले बताया था, F1 is the frequency of the class preceding the modal class, and F2 the frequency of the class following the modal class. Now, the class interval of the modal class is 10 because 29.5 to 39.5 means that the interval is 10. Applying all these values that we have determined in the formula of the mode comes out to be 35.8. Hence, we conclude that in this particular sample of managers of the child care centers, the modal age, in other words, the most frequent age, can be regarded as 35.8 years. All right, let us now locate the mode on the graph of this particular frequency distribution. Students, you will recall that in lecture number 4, we constructed the histogram of this distribution, and it was, as you now see, on the screen. Also, the frequency polygon was, as you now see, and superimposing the frequency polygon on top of the histogram, we obtain this rather interesting picture. But students, इस वक्त हम ये चाहते हैं कि हम इस ग्राफ के ऊपर मोड को लोकेट करें. As you know, the mode is a value of our variable x, और इसीलिए it is denoted by x hat. And in this particular example, because of the fact that x hat has come out to be 35.8, therefore, in this diagram, we locate this value on the x-axis. It is a point almost directly under the highest point of our frequency polygon. Please note that I said almost directly under. इसकी वजह ये है कि जो frequency polygon आप देख रहे हैं, as you will recall, that is constructed by joining the points which are plotted against the midpoints of the various classes. और अगर हम इस particular class का midpoint determine करें, the class which is the modal class, that midpoint is equal to 29.5 plus 39.5 over 2, and that is equal to 34.5. लेकिन x hat जो हमने इस फॉर्मूले से डिटरमिन किया, जो मैंने आपके सामने प्रेजेंट किया, उसके तहत x hat is equal to 35.8, which is somewhat to the right of 34.5. In fact, students, you should note that some statisticians even regard the midpoint of the modal class as the mode of that particular frequency distribution. But The formula that I have presented may be regarded as a better way of determining the accurate value of the mode. Students, the mode has some very desirable properties. It is easily understood, easily ascertained, and also one very important point is that it is not affected by a few very high or very low values. Students, इस सिलसिले में जो important point है वो ये है कि in which situations should we use the mode? Actually, it is a very valuable concept in certain situations, and I will try to explain this point with the help of an example. Suppose that the manager of a men's clothing store is asked about the average size of hats that are sold. He will probably think not of the arithmetic or the geometric mean size or even the median size. Instead, he will, in all likelihood, quote that particular size which is sold most often. Students, this concept of the most frequent value is of far more use to a businessman than the arithmetic mean or the geometric mean. The modal size of all clothing is the size which this businessman must stock in the greatest quantity and variety in comparison with any other size. So, आप देखते हैं कि inventory के point of view से this particular concept is very significant and much more important than some other measures of central tendency, which in some other situations may be very, very important. I said to you that I will also discuss with you the non-modal and the bimodal situation. कहने का मकसद ये है स्टूडेंट्स के बाज सिंपल डेटा सेट्स में एंड मुमकिन है कि there is no mode because all the values are occurring equally often. ऐसा मुमकिन तो है, especially if it is a small data set. इसके बरक्स, you can also have situations when you have more than one mode. And if you have two, that will be called a bimodal situation, and the graph will be as you now see on the screen. Students, आपको खुशी होगी ये बात सुन के कि there is a very easy method of differentiating between a unimodal and a bimodal situation. आपको पता है कि पाकिस्तानी कैमल जो है that has one hump, लेकिन जो चाइनीज कैमल है उसके दो humps होते हैं. That's the easy way to remember it. Students, this brings us to the end of the discussion regarding the mode. Let us now begin the discussion of the arithmetic mean. That value which is numerically the most representative of a variable series. Of course, as you know, this is the most widely used average. It is fairly, in fact, very easy to calculate, and it is the most well accepted. Let us have its formal definition. The arithmetic mean, or simply the mean, is a value obtained by dividing the sum of all the observations by their number. In case of sample data, the notation is x bar, and x bar is equal to summation xi over n, where I goes from 1 to n. Students, ये जो notation है sigma, इससे तो आप वाकिफ ही होंगे. This is capital sigma and it denotes the sum. इसके बरक्स small sigma जो है, that denotes the standard deviation, which we will be doing in a next lecture. In this formula, of course, xi represents the ith x value, in other words, the ith value of our data set. But for simplicity, We also many times write this formula as simply sigma x over n, यानी जो subscript I है उसको drop कर दिया जाता है. Let me now explain this concept with the help of a simple example. Suppose that we have information regarding the receipts of a newsagent for 7 days of a particular week, and suppose that the receipts are 9.90 pounds, 7.75 pounds, 19.50 pounds, and so on for the 7 days of the week, as you see on the screen. In order to compute the mean sales per day, all we have to do is to add the 7 values and divide by 7. And doing that, our mean sales value comes out to be 37.12 pounds. Students, let us try to interpret this result. This value, 37.12 pounds sterling, represents that amount which would have been obtained if the same amount was being obtained on each day. Students, just now we did the arithmetic mean in case of raw data. Frequency distribution के केस में हम arithmetic mean को किस तरह से compute करेंगे? The point to understand here is that in case of a frequency distribution, the identity of the individual observations is lost, as I mentioned earlier. What we do is that we assume that every value falling in a particular class is equal to the midpoint of that class, and using that midpoint, we compute the arithmetic mean or the geometric mean or any other such measure. The midpoint of any class is also called its class mark. Now, if we have k classes in a frequency distribution of a continuous variable, then our class marks will be x1, x2, and so on up to xk, and the corresponding frequencies will be f1, f2, and so on up to fk. Using these values, the formula for the arithmetic mean will be x bar equal to sigma fi xi over sigma fi, where I goes from 1 to k. It can also be written as x bar is equal to sigma fi xi over n, the simple reason being that the sum of the frequencies is equal to n, the total number of observations in our data set. For simplicity, we drop the subscript I, and our formula is x bar is equal to sigma fx over n. Let us apply this formula to the same example that we are very fond of, the EPA mileage ratings of the cars. In this example, the midpoints of the classes, as explained earlier, will be found by adding the lower limit of any class to the upper limit of the class and dividing by 2. And doing so, the midpoints are 31.45, 34.45, 37.45, and so on. Now, in order to compute the arithmetic mean, we first need to construct the column of fx, यानी x column की हर value को f column की जो corresponding value है उसके साथ multiply कर दीजिए. So, 31.45 into 2 gives us 62.9. 34.45 into 4 is 137.8, and so on. Adding the column of fx, we obtain 1135.5, and dividing by 30 our arithmetic mean comes out to be 37.85 miles per gallon. और इस वैल्यू की इंटरप्रिटेशन क्या है? That the average mileage of these cars tested by the Environmental Protection Agency is 37.85 miles per gallon. आपको याद होगा कि कुछ देर पहले हमने इसी एग्जाम्पल का मोड कंप्यूट किया था and that came out to be 37.825 miles per gallon. आप देख रहे हैं कि फर्क बहुत थोड़ा है, लेकिन बहरहाल एक फर्क है and that is obvious. After all, both of these, the mode and the mean, they are two different measures of central tendency. जब आपका फॉर्मूला ही डिफरेंट है तो ला मुहाला आपका आंसर थोड़ा बहुत मुख्तलिफ होगा. स्टूडेंट्स, यहां मैं आपके साथ एक बहुत इंपॉर्टेंट कॉन्सेप्ट डिस्कस करना चाहती हूं एंड दैट इज द कॉन्सेप्ट ऑफ ग्रुपिंग एरर. ग्रुपिंग एरर arises because of the fact that you have assumed in this computation that all the values falling in a particular class are equal to the midpoint of that class. जाहिर है कि इन रियलिटी तो वो सारी वैल्यूज जो किसी एक क्लास में फॉल कर रही होती हैं उसके मिड पॉइंट के बराबर तो नहीं होती. बट द मोमेंट यू यूज द एक्स वैल्यूज, द क्लास मार्क्स, द मिड पॉइंट्स in your computation of the mean, you are introducing this error. अब आपका जो आंसर आएगा, that will not be exactly the same as the answer that you would have got by using the raw data. Let us see what we have in this very example. You will recall that the mileage ratings of the 30 cars were 36.3, 30.1, and so on. And adding these values and dividing by 30, the mean mileage rating comes out to be 37.82. Students, the difference between the true value of the mean, that is 37.82, and the value of the mean that we obtained from the grouped data, that is 37.85, as you can see, it is actually very slight. और यही वजह है कि ग्रुपिंग एरर अरिथमेटिक मीन की कंप्यूटेशन में ज्यादा अहमियत नहीं रखता. Experience has shown that in the computation of the arithmetic mean, the grouping error is never serious. But of course, in the case of the standard deviation and in the case of some other quantities, the grouping error can have quite a significant effect on our answer. Students, the arithmetic mean is the predominantly used measure of central tendency of a data set. इस एग्जाम्पल में अगर आप उसके फ्रीक्वेंसी पॉलीगॉन पे दोबारा नजर डालें और एक्स एक्सिस पे अरिथमेटिक मीन को लोकेट करने की कोशिश करें तो अगेन यू विल फाइंड that it is lying in the center of the distribution. Not the exact center, but more or less in the middle of the data set. Students, the arithmetic mean has many desirable properties. As I said earlier, it is very easy to understand and to calculate. And one of the very important points is that it is based on every single observation in our data set. But the problem is that because of this fact that it is based on every value, sometimes, students, this mean is distorted. अगर आपके डेटा सेट में जो वैल्यूज हैं उनमें ज्यादा फर्क नहीं है, they are more or less the same, उस केस में तो अरिथमेटिक मीन बहुत अप्रोप्रिएट है. बट इफ there are a few very high or very low values in your data set, their effect would be to drag the arithmetic mean in their direction so that it no longer represents the bulk of the data, what it is expected to do. Let me explain this point with the help of an example. Suppose one walks down the main street of a large city center and counts the number of floors in each building. Suppose the following answers are obtained: 5, 4, 3, 4, 5, 4, 3, 4, 5, 20, 5, 6, 32, 8 and 27. Students, अगर इस डेटा सेट का अरिथमेटिक मीन कंप्यूट करें तो the answer is 9. But you should note that this is not at all a good representative of this data, because 12 out of the 15 buildings that we have just counted, they have 6 floors or less. Yani 12 out of 15, a very high percentage of the data, the bulk of the data, उन सब बिल्डिंग्स में तो 6 या उससे कम फ्लोर्स हैं, जबकि हमारा अरिथमेटिक मीन ये कह रहा है कि ऑन द एवरेज there are 9 floors per building. So this is exactly the way extreme values distort the arithmetic mean. In this example, the 3 skyscraper buildings have created a disproportionate effect on the arithmetic mean. Students, अभी हमने arithmetic mean का concept discuss किया है. उस arithmetic mean का जिसे simple arithmetic mean कहते हैं, या दूसरे लफ्जों में unweighted arithmetic mean. But then we have another very important concept, and that is the weighted arithmetic mean. बाज़ situations में हमें जो हमारी values हैं उनको weightage देनी पड़ती है, different weightage for every value depending on the situation. And let me explain this to you now with the help of an example. Suppose that in a particular high school there are 100 freshmen, 80 sophomores, 70 juniors and 50 seniors. And also suppose that on a given day 15% of the freshmen, 5% of the sophomores, 10% of the juniors and 2% of the seniors are absent. The problem is that what percentage of the students is absent in that school on that particular day on the whole. अगर हम इन वैल्यूज का सिंपल अरिथमेटिक मीन कंप्यूट करें तो हमारा जो आंसर आएगा that will be incorrect. If we do compute the simple arithmetic mean of the 4 values that we have, we obtain 15 plus 5 plus 10 plus 2 over 4 equal to 8. गोया हम ये कह रहे हैं कि on the average किसी भी एक category of students में 8% of the students are absent. But actually, it's possible for us to find out why this calculation is incorrect. और मैं आपके साथ इस चीज को स्टेप बाय स्टेप डिस्कस करूंगी. जैसा कि आपने देखा, जो फ्रेशमैन की कैटेगरी है उसमें हमारे पास 100 स्टूडेंट्स हैं. उनमें से 15% were absent. So this means that the total number of students absent from this category is 15. इसके बरक्स जो sophomores की कैटेगरी है उसमें total number of students is 80 and 5% of them are absent, but that means that the total number of students who are absent in this category is only 4. बिल्कुल इसी तरह 70 juniors में से अगर 10% absent हैं तो इसका मतलब है कि 7 स्टूडेंट्स एब्सेंट हैं और 50 सीनियर्स में से अगर 2% एब्सेंट हैं तो इसका मतलब है कि सिर्फ एक स्टूडेंट एब्सेंट है. In this way, the total number of students who are absent in this school on that particular day is 27. And if we divide 27 by the total number enrolled, that is 300, and multiply by 100, the percentage comes out to be 9%. आपने देखा था कि जब हमने अरिथमेटिक मीन सिंपल कंप्यूट किया तो हमारा आंसर था 8%, and that was wrong. Students, this brings us to a very important observation. और वो ये कि इस किस्म की सिचुएशन में जब हमारे नंबर ऑफ स्टूडेंट्स एनरोल्ड इन द वेरियस कैटेगरीज बराबर नहीं है, we cannot use the simple mean for the absenteeism figures. यानी हम उन absenteeism के फिगर्स को equal weightage नहीं दे सकते. We have to assign to them different weights in accordance with the group size for each one of those categories. इस example में ये जो group sizes हैं, they are acting as the weights, and we need to multiply each one of the absenteeism figures by these weights in order to obtain the correct answer. The formula for the arithmetic mean is sigma wixi over sigma wi, and applying it in this example, we obtain sigma wixi equal to 2700 and sigma wi equal to 300. Dividing 2700 by 300, we obtain the value 9. Exactly the same answer as what we obtained a short while ago as the correct value. So, it is obvious that there are certain situations where all the x values cannot be regarded as being of equal weightage, and in that situation, we modify the formula of the arithmetic mean and apply the formula of the weighted mean. The next concept that I am going to pick up is that of the median. Let me explain this concept with the help of an example. आपको याद होगा अभी थोड़ी देर पहले हमने वो एग्जाम्पल डिस्कस किया जिसमें हमने नंबर ऑफ फ्लोर्स इन द बिल्डिंग्स की बात की, और आपको ये भी याद होगा कि हमने देखा कि arithmetic mean it did not represent the data properly, because whereas 12 out of 15 of the buildings had 6 floors or less, our arithmetic mean came out to be 9 floors. इस situation में the median may come to our rescue. The median, students, is the middle value of a data set once we have arranged those values in either ascending or descending order. In other words, the median is defined as a value which divides a set of data into 2 halves, one half comprising of observations greater than and the other half smaller than the median. More precisely, the median is a value at or below which 50% of the data lie. Students, the median can be ascertained very easily in many situations, and especially in the case of raw data. Going back to the same example that I just discussed, the average number of floors in the buildings at the center of the city are 5, 4, 3, 4, and so on. And arranging these values in ascending order, we obtain 3, 3, 4, 4, 4, 4, and so on. Picking up the middle value, we obtain the median x tilde equal to 5. आइए अब जरा इस वैल्यू को इंटरप्रेट करते हैं. The median number of floors is 5. इसका मतलब क्या है कि out of those 15 buildings, 7 buildings have 5 floors or less, and 7 buildings have 5 floors or more, so that 5 is the middle value in that ordered data set. Students, जैसा कि मैंने एक से ज्यादा मर्तबा कहा, in this example, the arithmetic mean was distorted toward the few very high values. लेकिन median जो है, जो हमारा आंसर 5 है इस केस में, as you will all agree, this is much more representative of this data than the mean. मीडियन की यही खसूसियत है और यही इसका एडवांटेज है कि अगर आपके डेटा सेट में कुछ एक्सट्रीम वैल्यूज एग्जिस्ट करती हैं तो मीडियन के ऊपर उनका कोई इफेक्ट नहीं होता, सिंपली बिकॉज द मीडियन इज नॉट कंप्यूटेड बाय, फॉर एग्जाम्पल, एडिंग ऑल द वैल्यूज एंड डिवाइडिंग बाय द नंबर. वो जो एक्सट्रीम वैल्यूज हैं वो तो उसमें इन्वॉल्व ही नहीं होती. It is simply the middle value. Let us consider another example. Suppose that the retail price of motor cars for several makes and sizes is available to us, and the values are 415 pounds sterling, 480, 525, and so on. In this data set, there are 9 values in all, and after having arranged them in ascending order, the median price comes out to be 719. Once again, you notice that it is very simple. All you had to do was to pick up the middle value. Problem थोड़ी सी वहां पे आपको आएगी when you have an even number of values. देखिए, अगर आपके पास 8 values हैं, तो जो 4th value है, that is not the middle value. इसलिए कि 4th value से पहले 3 values हैं और 4th value के बाद 4 values हैं. इसी तरह if you say, all right, I'll pick up the 5th one, फिर वही problem है. अब 5th value से पहले 4 values हैं और 5th value के बाद सिर्फ 3 values हैं. So what do you do in this kind of a situation? What we do is to take the arithmetic mean of the 2 middle values. And I will explain this to you now with the help of the example that you now see on the screen. Suppose that the number of passengers traveling on a bus at 6 different times during a particular day were 4, 9, 14, 18, 23 and 47. इसमें डेटा, ये जो डेटा है इसको ऑलरेडी अरेंज्ड ऑर्डर में लिखा हुआ है. जरूरी नहीं है कि ये इसी तरह ऑर्डर्ड हो, but because we want to compute the median, we have arranged it in ascending order. Now, you can see that there are 2 middle values, 14 and 18. ये middle values इस तरह से कि अगर हम इनको jointly देखें तो इन दोनों से पहले भी 2 ही values हैं और इन दोनों के बाद भी 2 ही values हैं. Computing the arithmetic mean of the 2, we obtain the median equal to 16 passengers. All the examples that we have done until now pertained to raw data. What will we do if we have the case of a discrete frequency distribution? Let me explain this point with the help of an example. Suppose that we have the data regarding the number of pupils per class in some particular comprehensive school. Now, 23 students जो हैं ऐसी सिर्फ एक क्लास है. ऐसी कोई क्लास नहीं है जिसमें 24 स्टूडेंट्स हों. इसी तरह एक क्लास है जिसमें 25 हैं. But then we have 3 classes having 26 students each, and similarly we can interpret the entire table. अब पॉइंट ये है कि इसी डेटा को अगर हम रॉ डेटा की फॉर्म में लिखें तो वो बिल्कुल उसी तरह से एक अरेंज्ड डेटा सेट आ जाएगा जिस तरह से हम अभी थोड़ी देर पहले डिस्कस कर रहे थे. इन अदर वर्ड्स, in this case, this very frequency distribution converts to the raw data 23, 25, 26, 26, 26, and then 27 6 times, 28 9 times, and so on. Total 45 values हैं, and that is an odd number. So we don't have any such problem as having 2 middle values. अब 45 values का जो middle है, that is the 23rd value. इसलिए कि 23rd value से पहले you have 22 और 23rd value के बाद again you have 22. So you simply have to pick up the 23rd value and that is your median. लेकिन अगर मैंने इस डिस्ट्रीब्यूशन को दोबारा से रॉ डेटे में ही कन्वर्ट कर देना था तो व्हाट्स द फन. मैंने इसको फ्रीक्वेंसी डिस्ट्रीब्यूशन में तो इसलिए कन्वर्ट किया हुआ है ना कि मेरा रॉ डेटा जो है वो एक कंसाइज फॉर्म में आ जाए. मैंने ये पॉइंट जो अभी आपको दिया ये सिर्फ ये बताने के लिए कि इवन दो इट इज कंसाइजली प्रेजेंटेड इन द फॉर्म ऑफ अ डिस्क्रीट फ्रीक्वेंसी डिस्ट्रीब्यूशन, our goal is to pick up the 23rd value, and it is very easily achieved if we construct the column of cumulative frequencies as you now see on the screen. The cumulative frequencies are 1, 1, 2, 5, 11, 20, 28, 38, and 45. And the cumulative frequency 28 corresponds to the x value 29, whereas the cumulative frequency 20 corresponds to the x value 28. It is obvious that the 23rd value does not lie among the first 20, but it does lie among the first 28, and hence its x value is 29. यानी वो जो 23वीं ऑब्जर्वेशन है वो जो क्लास है that contains 29 students. Once again, how do we interpret this result? कि वो जो 45 क्लासेस हैं उस स्कूल में उनके जो क्लास साइजेस हैं वो जो एवरेज वैल्यू है, एवरेज क्लास साइज दैट इज 29. बट एवरेज इन व्हाट सेंस? नॉट इन द मॉडल सेंस, नॉट इन द अरिथमेटिक मीन सेंस, बट इन द सेंस ऑफ द मीडियन. कि अगर हम उन तमाम क्लासेस को असेंडिंग ऑर्डर में अरेंज कर दें बेस्ड ऑन द क्लास साइज, तो दरमियान वाली क्लास जो है उसमें 29 स्टूडेंट्स हैं. 22 क्लासेस ऐसी हैं जिनमें 29 से कम हैं और 22 ही क्लासेस ऐसी हैं जिनमें 29 से ज्यादा हैं. I think you will appreciate that the median is such a measure of central tendency in which this concept of center comes out very, very clearly. All right. Now that we have discussed the mode, mean, and median in considerable detail, students, let us consider another example that illustrates all three of these concepts. Displayed in the following table are the annual attendance figures in millions of visitors of 32 U.S. public zoological parks. The attendance figures are in millions: 0.6, 0.9, 0.2, and so on. For these data, measures of location can yield such information as the average attendance for the zoos, the middle attendance figure, and the most frequently occurring attendance figure. So, we would like to compute the mean, median, and the mode for the attendance figures listed in the above table. Now, students, of course, the computation of the mean is very simple. All we have to do is to add all the values and divide by 32. And in this way, we obtain X bar is equal to 1.3 million. Now, as far as the computation of the median is concerned, the first step is to arrange the data in an ordered array. And when we do that, we have 0.3, 0.4, 0.5, and after that 0.6 occurs 5 times, and then we have 0.7, and so on. Now, in order to compute the median, the first point to be noted is that in this example, students, we are dealing with an even number of values, that is 32. And you will recall that in the earlier discussion, it was mentioned that whenever we are dealing with an even number of values, we compute the average of the n by 2th and the n plus 2 by 2th values of the ordered data set. But students, here let me discuss with you another way of looking at this situation. As there are 32 values, we can say that the median is located at n plus 1 by 2th value, and that is 16.5th value. अब आप कहेंगे कि what do we mean by 16.5th value? All right. By the 16.5th value, we mean the value that is located halfway between the 16th value and the 17th value. Let me explain this point to you through the figure that you now have on the screen. अगर आप x-axis यानी real line पर 15th, 16th, 17th, 18th values को locate करें, तो जैसा कि आप देख रहे हैं, the middle of the distance between the 16th and the 17th values can be regarded as the 16.5th value. In other words, by the 16.5th value, we will mean the average of the 16th value and the 17th value, which is exactly the same as what we have been considering earlier. After all, students, is not 16 exactly 32 over 2, and is not 17 exactly equal to 32 plus 2 over 2? Yani, we are still doing exactly the same thing. The average of the n by 2th value and the n plus 2 by 2th value. All right. In this particular example, the 16th value is 1.0 and the 17th value is 1.1, and therefore, finding their average, the median comes out to be 1.05 million. Last but not the least, we are interested in the computation of the mode. Now, by inspecting the attendance figures, we find that 0.6 is occurring 5 times, whereas all the other figures are occurring less often. Hence, the mode is equal to 0.6 million. So, what is the conclusion? The conclusion is that the mean or the average attendance at the zoos is 1.3 million. The median, in other words, the middle attendance figure for these 32 zoos is 1.05 million. And the mode, that is, the most frequently occurring attendance figure is 0.6 million. Students, आज के इस लेक्चर में हमने सेंट्रल टेंडेंसी के 3 मुख्तलिफ measures discuss किए. We started with the mode, which was actually a continuation of what we had started last time. And then we went on to the arithmetic mean, and also its modified version, the weighted arithmetic mean. Lastly, we have discussed the median, and we have computed the median in case of raw data as well as in the case of the frequency distribution of a discrete variable. जैसा कि आपने देखा, इन तमाम केसेस में रॉ डेटा और डिस्क्रीट फ्रीक्वेंसी डिस्ट्रीब्यूशन के केस में मीडियन की कंप्यूटेशन बहुत ही आसान है. नेक्स्ट टाइम I will discuss with you the computation of the median in case of the frequency distribution of a continuous variable. The same EPA mileage ratings example that we are extremely fond of. और हम देखेंगे कि इस situation में we have a formula that will enable us to locate the median in case of a frequency distribution of a continuous variable. Also, I will discuss with you a very interesting concept, and that is the empirical relationship between the mean, median, and the mode. In the meantime, I would like to encourage you to attempt quite a few questions from the exercise of your textbook and also from many other books, as many as you can get hold of. And I wish you the best, and Allah Hafiz.